Hello and welcome back to Chemistry Talk with Hunter. I'm Hunter and today we'll be discussing types of chemical reactions and balancing reactions. So there's 5 types of main chemical reactions. There are 2 additional ones, those are redox reactions and acid-base reactions, but that won't be covered in this video. This video will just be the 5 main reactions because the other ones are a bit more challenging. So that's a separate video. So let's get started, naming reactions and balancing them. Okay, so I see our first reaction is a reaction of propane gas with oxygen gas, and we get carbon dioxide and water as a product. So this is a typical type of reaction where you have a gas plus O2, and you get water and CO2. Doesn't matter which comes first. And that is called a specific type of reaction, and that's called combustion. So that's a combustion reaction, so that's the first part. Now we have to balance it. And we balance equations by putting coefficients in front of already balanced reactants and products, chemically wise, charge wise. So I'm going to make a little bit of a bigger space there. Okay. So looking at this here, you don't usually want to start with hydrogen or oxygen balancing that because those are diatomic gases and you know it's easy to manipulate the amount we have of each. So let's start with carbon, which is not a diatomic gas, and let's see where that takes us. So I have 3 carbon over here, which means I need to have 3 carbon on the other side. You need to have the same amount of atoms of each element on each side of the equation. That makes it balanced. So I'm going to put a 3 here. Now I have 3 carbon on the right side. So that takes care of the oxygen, the carbon, my bad. Now I see we have 8 hydrogen over here. So the easiest way to make 8 hydrogen over here would be put a coefficient of 4 right there. That way we have 8. So now we have to balance our oxygen. We have 6 oxygen here from 3 times 2 is 6. And we have 4 oxygen here. So that means we have 10 total on the right side. How do we make this 10? We put a 5 here because 5 times 2 is 10. And that's the balanced reaction. So C3H8 plus 5O2 gives us 3CO2 and 4H2O. That's the balanced reaction. Okay, moving along. Sorry, my iPad fell. Okay. So here we have sodium chlorate, and that's decomposing, meaning it's separating into its constituent parts. It's separating into sodium chloride and oxygen gas. So right what I just said is the hint of the type of reaction this is. It's decomposing. This is a decomposition reaction. So you have one reactant separating into 2 or multiple products, usually just 2. Okay. Now let's balance it. We have NaClO3, and we get NaCl plus O2. So always check, you never know if you're going to get a balanced reaction. Usually not if it's a balancing test, obviously. But, in other areas of chemistry where you have to balance the reaction first, always check that it is balanced. So here's what I'm seeing. I'm seeing that we have 3 oxygen over here, and we have 2 over there. So the only thing I think to do is to find a common denominator, because there's no way I can make this 2 here 6. That's not going to happen. But I could by putting a 3 there, because I can make it 6 by multiplying it by 2. I can't make it what I was trying to say before. I cannot make it a 3. I can't make 2 into a 3, but I can make it 6 because that's our common factor there. So now I have 6O here, but still I have 3 here. So I need to put a 2 in front of there because 3 times 2 is 6. But now the sodium and chlorine are both balanced. Well, I put a 2 there to balance that. So that's the balanced reaction. 2 sodium chlorate equals 2 NaCl plus 3O2. And that's that reaction, the decomposition reaction. Okay. Okay, so this reaction looks a little bit more interesting. We have sulfuric acid plus sodium hydroxide gives us water and sodium sulfate. So two reactants and getting two products. That's your classic double displacement reaction. Why is it called double displacement? Well, you can think of it as hydrogen is displacing sodium and sodium is displacing hydrogen, and you just switch them and you get two products. However, this is a little bit different because water is not a reactant. We get water as a product because of the hydroxide plus the hydrogen. You can make water from that. So this is a water forming reaction, but in some double displacement reactions, you can easily identify how the two products were made. This is a little bit more involved. So let's balance it. Okay, so let's check if it's balanced. We have 2 hydrogen, okay, 1 sulfur, oh, but the sodium is off. Okay, so what I think to do here, the easiest thing was to balance the sodium first. So I'm going to put a 2 there to balance the sodium. Now I have 4 hydrogen on the left side and 6 oxygen on the left side as well. But I only have 2 hydrogen on the right side, and that's not going to work because I need at least 4. So what do? I put a 2 there to balance the hydrogen. Now I have equal amounts of hydrogen and oxygen on each side, and this is balanced. So that was not too bad. That was not as bad as it could have been. Could have been a little bit harder. Okay. Another type of reaction is when you have 2 elements combining to form one compound. That's called a synthesis reaction. And in this case, it's easily balanced because you have hydrogen gas, a diatomic, plus bromine, diatomic as well, gives you HBr, hydrobromic acid. But you can just put a 2 here. Whoops. You can just put a 2 there to balance the diatomic, and that's balanced. Synthesis reaction. Okay, last but not least, we have a single element plus a compound gives us a single element and a compound. So instead of it being double displacement, instead of 2 things being displaced, it's just 1 thing being displaced. So that's a single displacement reaction. So you can clearly see here that iron is replacing hydrogen in hydrochloric acid. So now it produces hydrogen gas and iron chloride. We could figure out what type of iron chloride it is because, iron chloride's ambiguous because chlorine has a -1 charge and there's 2 chlorines. So technically it produces iron 2 chloride. But that's a different video. Just wanted to point that out. So let's balance the reaction. Okay. So I only see one thing that's wrong here. The chlorine and the hydrogen are off. So the easiest way I see to fix that is to put a 2 right here. Now you've balanced the hydrogen and chlorine. And I just want to reiterate that I've told you about this compound right here because, oh, that's terrible handwriting. Iron 2 chloride. Because on the test, if you're ever asked, to write the word equation, which will be a separate video, from a balanced molecular equation, you don't want to forget that Roman numeral because iron chloride doesn't exist. Iron 2 chloride exists, iron 3 chloride exists, so you have to be specific. So I hope this has helped you in learning how to balance reaction and identify types of reactions. The reaction types, again, are single displacement, synthesis, double displacement, decomposition, and combustion, the main reactions. I hope this helped. If you have any questions about the concepts discussed, leave a comment below. Any requests for new videos, leave a comment below.